Hi, and welcome back once again. This is Amy Fuchsteiner, your instructor for elementary algebra. We are going to be working on the solutions to rational equations today. Notice we're not saying expressions anymore because these particular problems are equations, meaning we can find the value of x and let the world know what x is worth. So there is basically one sort of strategy here. We are going to multiply the equation by the least common denominator. Here it is again, that least common denominator, so important, this section, this chapter in general. So we're going to multiply each term by the lowest common denominator. But this is different than some of the ones that we've had because there will be the possibility that we have what are known as restricted values. We talked about this early in the chapter. These are values where the problem would mean we're dividing by 0. So we want to make sure that we have noted when those come up. Because we have variables in the denominator and because variables can be any value, we want to make sure that people are clear that we know and that they know when we cannot have a value, because that would put a 0 in the denominator and blow up the equation. We can't have the equations blown up. So for our strategy, first things first, we're going to list all the restricted values. That is, those values that x cannot be. Then we're going to go ahead and multiply by the lowest common denominator for the equation. That should cancel out all of our fractions, and we should be able to solve the resulting equation and check the solution. Now, we want to check the solution for two things. We want to be sure that we did not get an answer that would be one of the restricted values. Because if we say x cannot be 4, and one of the answers that works is x is 4, then we have a no solution. That's, what's that called when there's a disconnect, right? So we can't have that happen. But the other thing we want to do is we want to check any application problem for what's known as a reasonable answer. If they say, how long will it take you to get from point A to point B, and you get a solution of -20, time doesn't flow backwards. So we can't have a negative answer for a lot of applications in mathematics. So we need to make sure that we get rid of or knock out that solution in terms of its reasonableness. That's what we mean. Okay, so let's try a few problems. The first one here, problem number 1, is just a setup. As you look at this, we look again at our denominators, right? Our denominators are a 5, a 2, and a 10. There is no restricted value. Whoops, I really spelled values weird. No value restricted. Because our denominators are already a 5, a 2, and a 10, x is not in a denominator, our variable is not in a denominator, we have no chance of getting a 0 in a denominator here, right? So the next thing we'll do is look at our least common denominator. For 5, 2, and 10, our least common denominator is the 10. 5 times 2, 5 times 2 is already 10, so all of our denominators are covered. So what we're going to do, we've done this before, we did this way in the beginning, it's going to seem so old hat, is we're going to take the 3x over 5 equal to x over 2 plus 1 over 10, and we're going to multiply both sides of this by 10, right? When we do that, we're going to get 30x over 5 equal to 10x over 2 plus 10 over 10. That should be able to cancel, right? Oh, I got an itch on my nose. What does that mean? I'm going to kiss a fool? No fools coming my way. All right, so we've got 30x over 5. 30 over 5 is 6x equal 10 over 2 is 5. 10 over 10 is 1. Oh, I lost an x, didn't I? 10x, 5x plus 1. That's good. I'm glad I caught that. Now to solve this equation, I'm going to subtract 5x from both sides. And we do indeed get that x would have to be 1. To check this solution, I'm going to do, if x is 1, then I get 3/5 is equal to 1/2 plus 1/10. So that's 5/10 plus 1/10. That's 6/10, which is indeed 3/5. So yep, it checks. Oh, I was all out of range there. 1/2 is 5/10 plus 1/10 is 6/10, which is both reducible by 2. And yes, that is 3/5. So yes, it works. And my answer here is that x is equal to 1. Now, for the record, you may just want to go ahead and use your fraction key and do 1/2 plus 1/10. That would have been way quicker, and I get 3/5. So it does check with the 3/5. All right, let's try number 2. Are there any restricted values? Yeah, there are some restrictions. Our restrictions are that the denominator cannot be 0. So our restriction here is that x cannot be 0. That's it. Our least common denominator, the only thing in our denominator is x. So our least common denominator is x. So we're going to take 5 over x equal to 1 plus 3 over x. And we're going to multiply both sides of this equation by x, or x over 1. On the left side, this gives us 5x over x. On the right side, I have x plus 3x over x. Simplifying, 5 is equal to x plus 3, because the x's cancel here and here. I'm going to minus 3 from both sides. And we'll have 2 is equal to x. All right, we may want to check that one. And to check that one, we're going to put 2 in where x is. So this will be 5 over 2 is equal to 1 plus 3 over 2. And if I'm not sure, I do 1 plus 3 over 2. And I get 2.5, which converting is 5/2. Yep, so this guy checks. I am correct. And I can box that one. Whoop. Box it is. All right, we are boxed. You know they're going to get harder, right? Okay, so let's try the next one. Are there any restricted values? What's in your denominator? There's an x in your denominator, so the restrictions are that x cannot be 0. The least common denominator is just the x, because that's the only thing in our denominator. All right, so we're going to have a negative 6 over x is equal to 1/2 minus x minus 2 over x. And I am going to multiply both sides by that common denominator of x. That's going to give me a negative 6x over x equal to x times, that's going to be x over 2 minus x times x minus 2 over x. Right? This is all the numerator, so I need to put that in parentheses before I multiply. So it would be x parentheses x minus 2. Now, cancel. Ching, ching. Oh, shoot. My common denominator is an x, but it's also a 2. I should have done a 2x there. I should do top and bottom by 2x. That would have been a much better call. So this would be a minus 12. There we go. This would be a 2x, and that would be a 2x. Okay. That works much better. Because when you do your common denominator, all your denominators should go away. And I had a denominator left of 2, and that let me know I missed something. So in my common denominator, I should have put a 2x. Then 2x times negative 6 is a negative 12x. The x's still would cancel. 2x times 1 over 2 is a 2x over 2. And 2x times the x minus 2, the x's still cancel. All right, so that's going to leave me with a negative 12 is equal to x minus 2 times x minus 2. And now I just want to simplify this. So I got a negative 12 is x minus 2x plus 4. I'm going to subtract 4 from both sides. So I get a negative 16 is x minus 2x is negative x. 16 is my x. Now I want to check it. Okay, so if I'm going to check this, I'm going to have a negative 6 over 16 is equal to 1/2 minus 14. That's 16 minus 2 over 16. Negative 6 over 16 is a negative 3 over 8 because I want that reduced. So now I'm going to do 1/2 minus 14 over 16. I'm going to see if it works. Oh, it worked. Okay, good. Negative 3/8. So this checks. The only thing x cannot be is 0. I'm saying x is 16, so that's not a conflict. And there we go. Okay. Let's try number 4. Do we have restrictions? Our restrictions are that a plus 2, which is my denominator, cannot be 0. So a cannot be negative 2. My least common denominator is the a plus 2. There are no other denominators other than a 1 if I want to put that over 1. So I'm going to take my a squared over a plus 2 plus 4 over a plus 2 is equal to, I'm going to write that as a over 1. I'm going to multiply the left side by a plus 2. I'm going to multiply the right side by a plus 2. Okay. So this is going to give me a squared a plus 2 over a plus 2 plus 4 a plus 2 over a plus 2 is equal to a times a plus 2 over 1. Now cancel what you can. Ching, 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 ching. Nothing cancels here, but it's over 1, so that should not be a problem because it is over 1. It did that thing where it glitched, but I caught it this time. All right, so that's going to leave me with a squared plus 4 is equal to a squared plus 2a. I'm going to subtract a squared from both sides. 4 is equal to 2a. I'm going to divide by 2. 2 is equal to a. My restriction was that a could not be negative 2. So that seems to be okay, right? A cannot be negative 2. I got a as a positive 2, so that's all right. And then I might want to check this. If I'm going to check it, it's going to be 2 squared over 2 plus 2 plus 4 over 2 plus 2 is equal to 2 over 1. 2 squared is 4 over 4 plus 4 over 4 is equal to 2 over, well, this is 2 is equal to 2. So, yep, it checks. And I know that a value is equal to 2. All right, so far, so good. We're moving right along. All right. Problem number 5. Okay. Do we have some restrictions here? We do. It looks like we might want to factor this, right? Just like before. So if I look at this factor is x plus 2. This is x squared plus 5x plus 6. So it multiplies to give me a positive 6, adds to give me a positive 5. This is x plus 2, x plus 3. And this is x times an x plus 3. Okay, so what are my restrictions? I'm gonna need a little bit of room here. I have several restrictions. X plus 2 cannot equal 0. So x cannot equal a negative 2. X plus 3 cannot equal 0. So x cannot be a negative 3. And I know x cannot equal 0. Okay. Negative 2, negative 3, and 0. My least common denominator is the x plus 2, because that's in the first one. My second denominator has an x plus 2 already. I need an x plus 3. My third denominator has the x plus 3, but we haven't done the x yet, so I need an x. Okay. So I need to multiply each one of these terms by the x plus 2, x plus 3x. Okay. X plus 2, x plus 3 equals 5 over x plus 3. Okay, I'm going to multiply each side by x plus 2, x plus 3x, x plus 2 times x plus 3 times x. I just ran out of room, so I'm writing them vertically rather than horizontally. All right. So if I multiply this first term, the x plus 2's will cancel, and I'm left with 1x, x plus 3. If I multiply by the second term, the x plus 2, x plus 3 will cancel, and I'm left with a plus 11x. On the other side, the x and the x plus 3 will cancel, and I'm left with 5x plus 2. Simplify. X squared plus 3x plus 11x is equal to 5x plus 10. X squared's not going to cancel. I'm going to move everything over. Right? X squared plus 3x. So that's 14x. X squared plus 14x is equal to 5x plus 10. I can move the 5x over. X squared plus 9x. Oh, do you see what I see? If I move that 10 over, it'll be a minus 10 equals 0. We did these. X squared plus 9x minus 10. So what multiplies to give me a negative 10 but adds to give me a positive 9? X plus 10, x minus 1 equal to 0. Now I can use the 0 factor property. So either x plus 10 is equal to 0 or x minus 1 is equal to 0. So x would be a negative 10 or a positive 1. Okay, x is a negative 10 or a positive 1. My restrictions are negative 2, negative 3, and 0. So none of those are restricted. That's good. And then I would check them. I could check them. 1 over negative 1/8. Yeah. Okay, I'm going with it. 1/3 plus 11/12, right? Let's do the 1. 1/3 plus 11/12 equals 5/4. Yep. Okay. So the 1 works for sure. I didn't check the -10. I should check the -10. That would be 1/8 plus 11/100 minus 50 plus 6. 11/56. Let's delete that and insert my negative. I get 1/14. Oh, look at that. 5/70 would also be, okay, yep, they'll both work. I need a mental check. Both 10 and 1 won't. The checking is almost as long as the actual solving in some of these. So just be aware of that. I'm trying to see where I'm at for terms of time here. But it's okay. Number 6. We have a w over w squared minus 9. We have a w plus 3, w minus 3. So factoring first, because I've got a squared there, this would be w plus 3, w minus 3. It is the difference of 2 squares. So looking for our restrictions, we know that w plus 3 cannot be 0, meaning w cannot be a -3. And we know that w minus 3 could not be 0, so w cannot be 3. Our lowest common denominator is everything in the first, x plus 3, x minus 3. Checking to be sure that factor in the second one is included. Yep. And the factor in the third one is included. Yes. So I need to change my x to a w because that's what it is. But other than that, I'm okay. All right. So factored, this would be w over w plus 3, w minus 3, plus w plus 8 over w plus 3 equals w minus 8 over w minus 3. Okay. We're going to multiply the left side and the right side by w plus 3, w minus 3. And again, I'm out of room, so I'm going to write them horizontally because I prefer to write them vertically, but I'm out of room. All right, so w plus 3, w minus 3. Both of those will cancel, leaving with just a w. And the second one, it's the w plus 3. So w minus 3, w plus 8 equals. And then on the right side, it's the w minus 3. So that would be w minus 8 times a w plus 3. All right, this guy's a w plus. Now we're going to FOIL. W squared plus 8w minus 3w minus 24 equals. And then on this side, we're going to FOIL or double distribute w squared plus 3w minus 8w. And then we're going to have a minus 24. Okay, let's combine what we can. Whoops, I don't know why I had the blue one. So this would be a w squared plus 6w minus 24 is a w squared minus 5w minus 24. I am going to get everything to one side, so we're going to add 5w to both sides. This is going to give us a w squared plus 11w minus 24 is equal to w squared minus 24. Oh, I'm going to subtract w squared. I don't know why I didn't do that first. I certainly can. This is going to give us 11w minus 24 is equal to a minus 24. So now I'm going to add 24. And I have 11w is equal to 0. So w has to be 0. Okay, so if w is equal to 0, That's not restricted. The things that are restricted are a 3 and a negative 3, so that part is good. Will it check? Well, if I put it in for W, I have 0 over negative 9 plus 8 over 3 is equal to a negative 8 over a negative 3. That zeroes out, and I have 8/3 is equal to 8. Yeah, it checks. It checks. We're good. Yeah. Working great. Okay. What do we got coming up? 6, 7, and 8? Oh, yeah, just 2 more. Oh, we got to solve for a specific variable in a formula. Oh. Okay. No, just the same. We got this. We got this. We got it. We got it. We got it. Okay. Now, this is exactly the same thing you have been doing. We're just going to do the same thing. Multiply by the lowest common denominator and rearrange to get things out of the denominator. The problem with this is that sometimes with all the letters, it can start to feel a little bit alphabet soup-y. Not that you might not know the next thing to do, but when you're just looking at a bunch of letters, it can sometimes you swim a little bit, right? So just go real slow. We got this. All right. We don't do restrictions on this because we're just rearranging the formula. So we know that R1, R sub 1, and R sub 2 are all of our denominators, right? The thing you need to know about this that you may not be familiar with is that these all represent different things. So even though it looks like 1 times R and 2 times R, it's not. It's the first R and the second R. So our lowest common denominator will be R times R sub 1 times R sub 2. They are all different things. If you would rather substitute with different letters, feel free. Just remember to substitute back. So I'm going to take this 1 over R is equal to 1 over R sub 1 plus 1 over R sub 2. I'm going to multiply the left side and the right side by R times R sub 1 times R sub 2. Okay, looking at the far left side, the R is in the denominator, so it would cancel. This will leave me R1 times R2 is equal to, multiplying the first term, it's the R1 that cancels. So we'll have R times R2. Looking at the second one, it's the R sub 2 that cancels. So this is going to be R times R sub 1. Our instructions are to solve for R2. My brain keeps wanting to go R2D2, but that's not right. Okay, so what are we going to do? We're going to move all R sub 2 parts to the same side. So I am going to subtract R times R2 from both sides of this equation. Now, because it's all letters, I can't combine them like I would if they were numbers. The best I can do is write R1, R2 minus R times R2 is equal to R times R1. This puts the R sub 2's on the same side. The trick here is now to factor this out. Because I have now factored that R2, see how it was in both terms? It was here and it was here. Because I have pulled it out front, because I have factored it out, I can now divide both sides by the R1 minus R term, or factor. And this gives me R2 is equal to R times R1 over R1 minus R. Who would do this? This is an electrician's formula. So if for any reason you're here because you're going to be taking tech math and going into the electricians or the HVAC or even the electrical engineering track, you'll see this formula a lot. If you weren't already familiar with it, this is resistance. The resistance total, 1 over the total resistance, is equal to 1 over the resistance of we don't want to say channel circuit 1 plus 1 over the resistance of circuit 2, and then you keep adding them. 1 over the resistance of circuit 3, 1 over the resistance of circuit 4, and it just keeps going and going. So this is a common electricians and engineering formula. And moving it around like this happens all the time because that's how they test and check the different resistance levels. All right, let's try the last one. We're looking for L. The last one here, we're looking for L. So we want to make a mark on that. We're looking for the L, and then we want our lowest common denominator of 6D times 2, or 12D. So we're going to take F is equal to L squared over 6D plus D over 2. And we're going to multiply left side and right side by 12D. Okay, on the left side, this is going to give us 12